part of the Google Hangout on the Mercury Transit, a fairly rare event happening in a couple of days from now in early May. And we have a very great round this time again with us of specialists from various fields. We have a lot of things to say with respect to to Mercury transits. My name is Gernot Groemer. I'm with Austrian Space Firm. I am with Europlanet, which is an organization which links planetary researchers in Europe and around the world. It is funded by the European Commission under the Horizon 2020 program. And without further ado, I would say we would start with introduction of the people on the podium for tonight. Joining with me is David Rothery. And David, would you please introduce yourself as a starting point?
Well, hello everybody. I'm David Rothery. I'm Professor of Planetary Geosciences at the Open University here in Milton Keynes. I'm a member of the Bepi-Colombo team, and I'm very excited about the geology of Mercury. We've been using MESSENGER, that's the NASA mission, images of Mercury, and we're looking forward very much to the even better data we'll get from Bepi-Colombo. But the transit's a good chance to all get together and talk about what a great planet Mercury is.
It's an Earth-based taste of things to come, I would say. Jane MacArthur, also from the United Kingdom, is joining us as well for the first time for the Hangout. Jane, please.
Hi, I'm from the University of Leicester. I'm a PhD student and I'm studying Martian meteorites and comet samples there because I'm still waiting for David to bring me back some rocks from Mercury before I can pursue that further. However, I'm also here because I won a space on the Meet ESO social media tour in Chile, where we'll be viewing the transit out at the Paranal Observatory, and looking forward to that. It should be fantastic.
Joining us now for this time from the eastern part of Austria is Johannes Benkhoff with the European Space Agency. Johannes, you are right in Vienna, but you're not Vienna-based usually.
No. Hello, everybody. Johannes, and I work for ESA as a Bepi-Colombo project scientist. I'm located at ESA Aztec, which is in Noordwijk in the Netherlands, and yeah, we are about to launch Bepi-Colombo in less than 2 years now.
Which seems like a long time, but for space mission planners, that's tomorrow, isn't it?
It's all, and we are already very excited about it.
Very well. Joining us from Italy, we have with us Valentina Galluzzi from INAF. Good evening, Valentina.
Good evening, everyone. I am Valentina Galluzzi from the National Institute of Astrophysics in Italy. I'm a planetary geologist, and during my PhD, I studied Mercury and its surface. In fact, I'm a planetary mapper and do geological maps of the surface of Mercury.
So you're basically an alien cartographer, could we say that?
Yeah, you could say that.
I'm a cartographer for alien worlds, I put it this way. Well, ladies and gentlemen, let's dive right into it. Actually, what's going to happen on the 8th of May is something which is not super rare, but it's not an everyday event. David, could you maybe elaborate a little bit about what we can expect to see on the 8th of May, to have some idea about the sequence of events and what we can expect in terms of expectation management?
Okay, well, it's actually 9th of May.
Oh, sorry.
Monday, the 9th of May. So that's 2 weeks on this coming Monday. Mercury is going to pass in front of the Sun. Now, Mercury is a very tiny object. Its diameter compared to the Sun is 150th the size of the Sun, as we will see it crossing the Sun's disk. So you can't see it with the naked eye, and you shouldn't attempt to, because you shouldn't look straight at the Sun. And you certainly shouldn't look at the Sun through a telescope unless it's got a professional filter in front of it. So go and join a party that knows what they're doing. Project the image of the Sun or have a proper solar filter in front. It's a tiny little dot. It's going to be good to see. I'm looking forward to see it. I've seen one transit of Mercury, and I'm looking forward to seeing another, because when I saw my previous transit, I wasn't involved in Mercury science, and now I am. So I'm going to see my planet silhouetted against the Sun. It's going to last for 7.5 hours. It starts at 11:12 universal time. That's 12:12 British summer time, or 13:12 Central European time, and it finishes 18:42 UT, that's 2042 European time. I'll just share a screen and show you what you might expect. So I'm hoping you can see this picture here.
We can see it.
Okay, so at 11:12 Universal Time is contact 1. That's when Mercury appears on the edge of a sun's disk. Contact 2 is when it's fully on the sun's disk. That's 3 minutes later. Then it will spend the next 7.5 hours slowly crossing the face of the sun. It should reach the edge of the sun at 1839 Universal Time, 2039 Central European Time, and be fully off the sun. That's contact 4, C4 on this diagram, at 3 minutes later. And schools are being invited to make timings of the second and third contacts. That's when Mercury is first fully on the disk and when it reaches the far edge of the sun's disk, and to measure those timings exactly, because the importance of transits historically was that by measuring how long it took a planet, either Mercury or Venus, to cross the disk of the sun from different locations on the Earth was a way to work out the scale of the solar system. So the European Space Agency has a site which invites schools to send in their transit timings and contribute to a modern measurement of the size of the solar system. Now, it won't improve what we already know, but it's a good exercise to do what very famous astronomers did in the past for real when we did not know the size of the solar system. So it'll be fun to watch, and there's lots of transit events happening all over Europe. Again, the European Space Agency has a website which you can find by searching, or find from the Europlanet website, but will take you to the ESA website where there's a list of transit events that people can go along and watch for transit in the company of local astronomers.
Absolutely. So we cannot really expect a dimming of the sunlight like a lunar eclipse. It's not like a Venus transit where I see a big black dot going through the sun. It rather looks like a sunspot. Could you say that?
It will be smaller than the biggest sunspots. It might look slightly darker than a sunspot, but you're looking at dark objects on a very bright surface, so that effect may not be apparent. But perfectly round, very tiny, slowly moving spot. But I'm going to be excited. The hairs on the back of my neck will be standing up when I'm watching it.
That sounds very exciting. It's also, however, if you choose to observe the Mercury transit, you must be aware that you still get almost all of the full sunlight, and if you have any magnification means, this can actually be a very dangerous thing. Yeah. Which brings us actually also to the question of safety. David.
Safety. Well, I think I said, do not look through a telescope, do not look through binoculars. You can get professional sun filters to fit in front of a telescope, that's fine, or you can project an image of the sun with binoculars or a telescope onto a card and do it that way. But just bear in mind that with the full aperture collecting the light, that the focus is going to be very, very hot, so do not get your eye, do not even put your hand there. But you can project an image. But it's better to watch online, you'll see a clearer image because we've got satellites in space with no clouds in the way, or go to a local transit event where there are people who are used to looking at the sun who can help you do it safely. But there are also videos online which show you how to watch safely.
Well, so given the timing, actually, this transit is a perfect lunch break science activity, I would say, because wherever you are in Europe, if you have a late lunch break, you might be able to see the beginning of the transit phase. So it's a lunch break event for us Europeans. It might be a breakfast event for another geographical group. Jane, in a couple of days, you will embark for a very adventurous journey to a very unusual place. So, Jane, if you could share us a little bit about what you're going to expect for the next few days then, starting.
Yes, so with the Meet ESO competition, we'll be flying out on the 6th of May and congregating that night. And then we're going up to Paranal. I think there's a flight and a road trip involved, and we'll get a day's tours around the observatories to find out what the astronomers do there. I think we get to see the very large telescope opened up that evening. And then the next day it's going to be the transit of Mercury. So we'll be viewing that in the morning with some amateur telescopes there. Coincidentally, I've discovered that another one of David's colleagues at the Open University, Colin Snodgrass, is going to be observing out there at the time. And that evening, he was going to be observing Comet 67P, so we might be able to see the comet that Rosetta's still tracking. So that's a little bonus for us. But we should be able to see a good portion of the transit. I think we're basically watching the first half, and then they've got some more tours and facilities for see of all the remarkable work ESO do. And then we're moving on to San Pedro de Atacama, which is the town nearest the ALMA, the Atacama Large Millimeter Array. And there, provided we pass the medical test, we should be allowed up to the 5,000 meter plateau where all the radio antennae are. There's about 60 of them, I think.
We do have a question from our audience, and by the way, whoever is listening in, I see the numbers going up quite steeply right now. If you have a question, there's a small tab box on the right with Q&A, so you can ask questions, and I will filter those questions. The best questions will then put forward here to our experts. Like there's one from Silvia Jimenez, and she asked, what kind of information from Mercury are you expecting to get from this transit? Now, David, I understand that previously those transits have been used as a measuring stick for the size of the solar system. Are you aware of any science still going on here that we would need or would like to have more precise measurements?
No, I'm not. I mean, when Venus goes in front of the Sun, you have a chance to study its atmosphere, which is the same principle we use when exoplanets go in front of other stars. But the exosphere, the atmosphere of Mercury, is so tenuous, I don't think any measurements are going to be achievable of Mercury's atmosphere. So it's not really a big thing for science, it's a big thing for education, because as I said, observing transits was very important in the past when we weren't sure how big the solar system was.
So also for specialists, it's an event to enjoy and sit back, relax, and see the solar system at work.
It's an event to enjoy and also to say to people, look, this tiny black dot is actually a marvelous planet. It's got volcanoes, it's got fault scarps, it's got lots of craters, it's got a magnetic field. Perhaps Johannes is going to be talking about this, but it's a wonderful world, and we want people to know what a great world it is and what a great mission Europe has prepared to send there.
Speaking of which, thanks, David, for mentioning that. I was just about to start that part of the conversation. Actually, we just got not a question, but a link to the cosmosesa.int website, where the Bepi Colombo Mercury Transit website is up, and there's a lot of things which are being displayed during the actual event. There is a lot of background information, but also live imagery from satellites. So although Bepi Colombo is not yet in orbit, or not yet in its transit towards the planet, however, Johannes, I'm sure you're getting more excited as we're getting close to the mission itself. For our viewers who have not heard so much about Bepi Colombo yet, because it's still a mission in the making, so to say, could you give us a rough overview about the mission itself?
Yeah, of course I can. Bepi Colombo is a very fantastic mission because it's a mission which we do together with the Japanese Space Agency. Actually, we are not sending one spacecraft, but we are sending 2 spacecraft to Mercury. And one spacecraft is provided by the Japanese Space Agency, and this spacecraft is dedicated to the environment around Mercury, because Mercury is so close to the Sun that the solar wind interacts a lot with Mercury. And Mercury also has not an atmosphere like Earth, but it has only very thin exosphere, we call it, and therefore the radiation from the Sun interacts with it very heavily. And we have one spacecraft from the Japanese agency who studies all the processes are going on there. In addition, we have the so-called Mercury Planetary Orbit, which is dedicated for remote sensing of the planet itself. So we will provide 3D images of the whole planet. We have spectrometers on board, the UV and the X-ray and the gamma ray, to get information on the composition of the planet, what elements are. And so we are very excited that we can do that. In addition, and David just mentioned it, the Americans had recently a mission in orbit for almost 4 years, and they showed us that Mercury is a very fantastic planet, not as boring as the Moon, but had a lot of surprises for us we did not expect. There's a high content of volatiles on the surface, which was not believed in the beginning for a planet which is so close to the sun. And all these things we can follow up with Bepi-Colombo because we are equipped with a lot of very sensitive, good instruments to follow on this and do a very comprehensive exploration of Mercury.
That sounds fantastic. I remember when in 1996 we did a Mercury orbital study back at the Altbach Summer School with a couple of students, and we were also considering a lander, for example. There, I remember we were looking for the perfect material, how to absorb the impact shock wave and also have a good isolation factor in terms of thermal conditions. And remember, the perfect substance we chose back then was aspirin, compressed aspirin. As a perfect substance, but unfortunately the latter didn't make it in the final selection, obviously, although I think in the very beginning of the mission there was some idea about landing something on Mercury.
In the early studies, or when the proposal came in 1993 already, there was a lander and people were thinking about a lander, and at that time we had actually 3 units of spacecraft in which we wanted to send to Mercury. But unfortunately, for monetary reasons, we had to descope our plans around 2000, 2003. But I guess also without a lander, with our 2 spacecraft, we are very well equipped to get wonderful science for Mercury.
Absolutely. And I think with those planets where we're just learning how to understand them, it's almost like opening a door to a library, studying the surface, and so many stories which are being told if you know how to listen to it. Valentina, you have been working on that topic for a long time, and since your PhD days, on mapping and studying the surface. So if you would describe, if I show an image of Mercury to you know, elementary school kids, they would say, "Oh, it just looks like the moon." I guess you would disagree with this statement, wouldn't you?
Yeah, because I know Mercury looks so gray and so full of big holes like the moon, but actually it is a bit different. And just as Johannes said, it is a very exciting planet. It is a very interesting planet. You have to know that Mercury is shrinking. It means that it is slowly getting smaller and smaller. This means that its surface gets, in time, it gets wrinkle on the surface. And these wrinkles, we call them folds. Mercury has a lot of contractional folds on its surface, and it's very particular for a geologist like myself to study a planet who is contracting all over its surface. These folds are called lobate scarps, and they are like long scarps which have many lobes because they are actually the surface expression of low-angle thrusts, which are contractional folds. Yeah, so that is very interesting to study this.
So the surface is shrinking and making wrinkles like an old person as a human, I would say.
Yeah, exactly.
You could also say that Mercury did not have an easy childhood, I would say. It is a better child in a way. And maybe you want to elaborate a little bit about the past and why you could say that, well, the childhood was a very forceful one, I would say.
Yeah, Mercury is shrinking and, as you said, getting older because of its core. The core of Mercury is very large. And it is still partially melted, but this core is slowly cooling down and getting solid. This means that the volume of Mercury is getting smaller, and so its surface has to contract, like the surface of an orange, for example. Yeah.
Well, David, coming back to you, I understand you have been writing a book about the surface of Mercury as well. The entire planet, of course, not just the surface, of course. I think one thing that might be interesting from a human point of view is imagine you'd be standing as observer on the surface of Mercury. And as we said, there's much more stories to tell than on the moon because there has been a more diverse history or so many things happening still on the surface with the outgassing and so on. But if you would just watch a typical day on Mercury, what would it look like?
Okay, well, yes, I did write a book about Mercury. There it is on the shelf behind me. If you were standing on Mercury, well, surface gravity is about 1/3 what it is on the Earth, so that's twice what it is on the Moon. So you would still feel quite light. You'd be standing on a very powdery regolith surface, like on the Moon. Very little bedrock exposed. It's been pulverized by impact, so it's regolith. But in the sky, suppose you're on the equator, the sun wouldn't move very quickly across your sky because Mercury rotates very slowly. It actually rotates 3 times for every 2 orbits around the sun. That means from sunrise to sunrise, it actually takes 2 of Mercury's years. So the sun creeps very slowly around your sky. We used to think it kept the same face to the sun all the time, but that's incorrect. 3 rotations for 2 orbits. And it'd be very hot by day. It's over 400 degrees Celsius by day, but it's well below minus 100 degrees at night. So big temperature contrasts. And because its orbit is not circular, it's the most eccentric orbit of any planet. It's about 1/3 of the distance from the Earth. Mercury's distance from the Sun is about 0.3 of the Sun-Earth distance when it's closest, and about 0.4 of that distance when it's furthest away. So it's an eccentric orbit, and when it's closer, it's moving faster, and that means the Sun moves a bit faster across the sky, or appears to, than it does when it's further away. So if you're standing at the right place, you'll see Mercury change direction across the sky a little bit. And if there are 2 longitudes on the planet, where you could see Mercury set and then rise and then set again over a course of about 40 hours or something, because of its changing orbital speed. Its rotation is exactly constant, but its orbital speed depends on its distance from the Sun. So you'd have very strange days on Mercury, and they'd be twice as long as a Mercury year. So Mercury takes 88 days to go around the Sun, so that's 176 days from sunrise to sunrise.
And still, although it's so close to the Sun, there are still places where you could consider going ice skating. Is that true?
There are
very dirty ice skating
holes where the Sun never shines, because Mercury's axis is not inclined to its orbit. So craters have permanent shadows in the bottom, and there is water ice there. We know that from measurements taken by Messenger, and we suspected it from radar observations from the Earth. But it's ice buried below the regolith, or mixed in with the regolith and mixed with other stuff. It's not smooth ice that you could skate on.
Yeah.
And even if it was a complete sheet of ice, it would be too cold to skate on, because it's minus 100 centigrade, or it's lower than that, minus 150 centigrade. The ice wouldn't melt below your blades, which is what you need to allow an ice skater to move. So forget about ice skating on Mercury. It's not a place for winter sports.
Johannes, let's go back into Mercury orbit once Baby Colombo arrives there. One thing that always stuns me and I find so fascinating is the engineering challenges of surviving in this not really benign environment, given all the radiation, all the heat Baby Colombo is going. Can you elaborate a little bit how a spacecraft can survive so close to the Sun where you could met some metals even on the surface?
Oh, what you need is some special shielding, and we have, especially for Bepi Colombo, developed a kind of multi-layer insulation that is a fabric like the clothes of firemen, which are firemen wearing when they have to fight against bushfires. And it's a multi-layer, it's about 18 layers as far as I recall, after each other to keep the inside of the spacecraft at room temperatures, while outside, as you heard from David, we have temperatures around 300, 400 degrees Celsius. And we tested it. We have at ESTEC in Nordwijk facilities where we can simulate the environment around Mercury with the cold temperature, but also the hot sun of 10 solar constant. and we tested our insulation and the design, and it worked perfectly. So now we are pretty sure that we can withstand the heat which we expect from Mercury and from the Sun at that time. And I think our engineers did fantastic work on that.
So do you have some idea about the expected temperatures in the interior of the spacecraft?
Oh, as I said, it's room temperature, so the temperatures are between -10 and +40 degrees. So it's for electronics and everything, it's very reasonable temperatures. So everything should work smoothly if there are no heat leakages, which we hope there are not.
Is there anything that could go wrong in terms of creating heat leakages, like I don't know, a micrometeorite hitting in the transit phase? Is this a risk you have to consider?
Since the layers are so thick, I guess these micrometeorites, if they are small, they will not harm us a lot. Of course, we have also to get rid of some of the heat we generate with all our electronics. And for that, we also have a big radiator on one of the side of the spacecraft. And this radiator is not allowed to see the sun. It should always look into dark space. And of course, if something goes wrong and the radiator points to the sun for more than 90 seconds, then we are running the risk that the spacecraft and gets too hot. But if everything goes fine, we have safe modes installed where in case we lose control of the spacecraft will automatically put itself in place that this radiator will look away from the sun to the dark space. So also here, I think we are quite safe.
Awesome. All the best for this really fantastic mission. We got an interesting question from Michael Russwurm, and I'm not sure whom to address to. Maybe Valentina might be a good target for this question. So it says, so it was about the temperatures we were talking about, that the poles are cold and the non-polar regions are very hot or so. So the question is, so in the twilight zone around the poles, a more human sustainable temperature would be possible. Are there areas where you could have living room temperatures on Mercury?
Well, I'm not sure, because I think you should move with the Terminator of the Sun, I'm afraid, because the Mercury temperature delta excursion is so high. So I'm not sure. We should ask maybe an astronomer, but I wouldn't live there, because the temperature is switching so much, and the difference in temperature is so high. So it would be very difficult to find a zone, even the twilight zone, where the temperature is human sustainable. But maybe Dave can say something more.
Yeah, I think it would be difficult, but you could probably find a few places where you had just the sun on the horizon, or half the sun above the horizon, year-round grazing incidents, and the temperature would be always around about 0 Celsius. You could have solar power all the time, and half a kilometre away you could have a crater with some ice, which you could use as a resource.
Maybe inside a crater, yeah. Maybe inside a crater.
It would be difficult. I think we'll have bases on the lunar poles long before we have bases at Mercury's poles.
Yeah.
I guess so too. Well, it seems there's really a lot to see in the next years. I'm very much looking for the first data sets to come back. Johannes, as a personal question, and I know you should never ask a project scientist what's your favorite instrument, because that would be a very political question, of course. However, could you give us a gut feeling, a vision of what kind of data set you say, well, this is, if I had the choice, this is the one I'd really love to have first, because it might be so exciting, which would promise us the most spectacular new knowledge about Mercury, that we call about Mercury. Is there anything of any data set where I say, well, this is the one I'm really scratching my nails onto?
Oh, actually, as you said, normally I would not take position and go in favor of one experiment to the others. But before I came to this project, I worked at the DLR of Berlin, and there I was involved in the development of one instrument which is actually flying now on Bepi Colombo. This is a thermal infrared spectrometer. And with the thermal infrared spectrometer, that is something which also was not on board of Messenger. So there is a range in the thermal infrared where we have so far no data of. And of course, seeing some thermal infrared data from the planet, from this MERTIS instrument, would be very nice and a fantastic new result. But as you said, all the other instruments are as important, and I guess the first images, the first magnetometer readings, the first plasma reading, everything would be very exciting.
This was a perfectly diplomatic answer, Johannes, I have to say, because it is perfectly okay to have some father feelings for an instrument you have been working on before you joined ESA, so that's perfectly acceptable and politically okay, I would say. Well, having said that, I think this was a nice closeout actually of this Google Hangout. Again, thank you very much, Valentina, Galluzzi from INAF, Jane MacArthur from the University of Leicester, Johannes Bank from ESA, and David Rothery from the Open University. My name is Gernot Groemer. I'm with Europlanet, which links planetary researchers across Europe and the world, funded by the European Commission under the Horizon 2020 program. This this entire session will also be posted as a YouTube video. The link is already out there already if you haven't had the chance to watch the entire Hangout. Otherwise, I wish you all the best for all of us for getting a clear skies view on this marvelous event on the 9th of May. Wherever, if you're having lunchtime in Europe or breakfast in Chile, there's no excuse for not watching it, even if you have bad weather. There's a link out there from the Cosmos website of ESA, which we posted just recently, where you can actually watch it from space with a live downlink from the spacecrafts. Having said that, I wish you all the best. Thanks for watching, all of our viewers, and see you again in one of our next Europlanet Google Live Hangouts, when we go actually into planetary researchers' laboratories and also some field expeditions in the upcoming months. Good evening and have a great time.
Bye.
Bye-bye.